This is Chem 121, Chapter 2, Section 2.8. On this section, we're going to do dimensional analysis. I would like to start out this section with this slide. Hopefully, after we go through the steps for dimensional analysis, these kind of problems will be more straightforward and you'll have a method for solving them. So students always ask me if there's a trick to solving problems, and I tell them yes. The trick is you just have to have a series of steps to solve them and follow your steps. You have to identify where you're starting and where you're going. And I always like to compare it to using the map app on your phone. We're going to use the same 4 steps in all of our dimensional analysis problems. They're always going to be the same 4 steps. And I'm going to use these 4 steps in every problem that I solve in the class. You want to read through the problem. You want to identify what you want to find and write that down on the right-hand side of your page. You want to write down what you're starting with and write that down on the left-hand side of the page. You want to put a conversion factor in the middle and convert your units and cancel them. And then you want to write down your conversion factors in what I like to call the toolbox and fill in your numbers. So I'm going to show this on the whiteboard real quick, and then we're going to solve some problems. So the 4 steps are figuring out what you want to find and writing that down first. So this is what you want to find, and you write that down on the far right-hand side of the page. And then the second thing is to write down what you're starting with. So this might feel kind of opposite or kind of backwards from the way you normally solve problems. Writing down what you want first, what you're trying to find, and then write down what you're starting with second. And then the third step is writing a conversion factor in between these 2 things. And you're going to use that to cancel out your units. Whatever unit you have here is going to go on the bottom, and whatever unit you have here is going to go on the top. So for example, if you have milligrams here and grams here, you're going to want to put milligrams on the bottom so you can cancel those. And you're going to want to put grams on the top because grams are going to be your answer. And then the last step was you're going to put your numbers in and you're going to solve the problem. And I call that the toolbox. So your toolbox for a problem like this would be the equality and the conversion factors between milligrams and grams. So 1 milligram would equal 0.001 grams. This would be your toolbox in a problem like this. 1 milligram is 0.001 grams because milli is equal to 0.001. And then you would write out 0.001 grams over 1 milligram, or 1 milligram over 0.001 grams. Those would be the 2 equalities or conversion factors that would go with this equality. And then you would just figure out which one of these conversion factors you would want to put into your problem. So since we have grams on the top and milligrams on the bottom, we would use this one, the 0.001 grams over 1 milligram. And then just whatever number was here. I didn't put a number in it. Be this number times this number to get your answer. So the steps are what you want to find, what you have, your conversion factor here in step 3, and then your toolbox to fill in the answers. And we'll do some examples of these so you can see how these 4 steps work. So again, here are the 4 steps. And let's look at some examples of this. So here's an example. A physician ordered 100 milligrams of Demerol. Demerol is available as a 50 milligram per tablet. How many tablets should the nurse administer? So the first step, we go back to our 4 steps. The first step is to write down what you want. What are you trying to find? So when we read through the problem, they've given us some information about 100 milligrams of Demerol and how it's available. How many tablets should the nurse administer? When you're looking for what you want in a problem, you're always looking for a sentence like this. How many, how much, how far? There's always a question in the problem that tells you what you're looking for. And in this case, you're looking for a number of tablets. So we write that down over here. How many tablets? That's your step 1. And then what are you starting with? Well, you have 2 possibilities here. You could start out with 100 milligrams of Demerol, or you could start with the fact that Demerol is available as the 50 milligrams per tablet. When you have 2 units, that's almost always going to be your conversion factor. That's almost always going to be what goes in your toolbox. The 50 milligrams per tablet or tablet per 50 milligrams. Almost 100% of the time, you're going to start out with the thing in the problem that just has a single unit in it. There will be rare circumstances where you start out with a thing that has 2 units, but that's really unusual. Almost all the time, you're going to start out with a thing that has 1 unit. And in this case, that's the 100 milligrams of Demerol. So let's put this over here. That's what you're going to start with, number 2. Then we draw our line in the middle. That's our conversion factor. We want to put the milligrams on the bottom because we want the milligrams to go away because we want tablets in our answer. So we're going to put milligrams on the bottom and tablets on the top. We want the milligrams to cancel and we want tablets in our answer. So down here in our toolbox, our 50 milligrams per tablet can be written as 50 milligrams in a tablet or 1 tablet in 50 milligrams. And it turns out that's the one we want to use because tablets is on the top and milligrams is on the bottom. So we have tablets and we have 50 milligrams on the bottom. So to do our math, we take 100 milligrams and we divide it by 50 because it's on the bottom. The milligrams cancel out and we get 2 tablets in our answer. Now, when you have something that is not a measured thing like a tablet, you don't have to worry about the sig figs. So when you have capsules or tablets, don't worry about the sig figs. The answer would just be 2. So here's a learning check for you that's similar to the one that we just did. So hopefully you had a minute to work on this problem. We're looking for a number of tablets. The physician ordered 20 milligrams. We're going to use our 10 milligrams per tablet or tablet per 10 milligrams in our toolbox. We're going to put milligrams on the bottom because we want to get rid of those and put tablets on top because that's in our answer. And then 20 divided by 10 gives us 2 tablets for our answer. Those are our 4 steps. What we want, what we have, our conversion factor, and then finally at the end, we put our numbers in from our toolbox and get our answer. Let's do another example. Here, the doctor's order is 1.2 grams of folic acid. Folic acid is available as 800 milligrams per tablet. How many tablets should be taken? So again, in this problem, we're still looking for tablets. Our 800 milligrams per tablet is going to be in our toolbox, and we're starting with grams. In this problem, though, our toolbox is in milligrams, and we're starting out in grams. So we have to add a second step where we convert the grams into milligrams. So first we do a conversion of grams into milligrams. We put grams on the bottom and milligrams on the top. Notice I'm not putting any numbers in here yet because step 3 is just about the conversions. if we go back to our steps, it's just units. Step 3 is always just about the units. We don't do anything with numbers until step 4. So when we're on step 3, we're just converting the units. We're not putting any of the numbers in. So we're converting our grams into milligrams. Now we can use our milligram per tablet part of the toolbox, where we put the milligrams on the bottom and the tablets on the top. So now we can cancel out our grams, we can cancel out our milligrams, and we have tablets at the end. Finally, in this step, we put our numbers in. Milligrams to grams is a metric conversion that we've seen before. 1 milligram over 0.001 grams, or you could write it the other way, 0.001 grams over milligram. And then our other toolbox is tablets over 800 milligrams or 800 milligrams per tablet. It's always good to write your conversion factors out both ways so that when you go back up here, you can decide, is it milligram over 0.001 grams or grams over 0.001 grams over milligram. You have to decide where the numbers are going to go. In this case, since the milligrams are on the top, the 0.001 grams go on the bottom. And since tablets are on the top, the 800 milligrams go on the bottom. Now for your math, I think the easiest way to put this in your calculator isn't top and bottom, it's left to right. So actually take your calculator, type in 1.2 divided by 0.001, then hit the equal sign right here. Then type divided by 800, and you'll get 1.5. Again, 1.2 divided by 0.001. Just hit the equal sign here and hit divide by 800 and hit equals again. It's easier to do your math left to right, exactly the way the problem is written, instead of trying to do it top to bottom. So here's a learning check for you that's similar to the problem we just did. So again, we're trying to find tablets. We're starting with 1 gram of calcium. Our conversion factor is milligrams per tablet. So in this example, we have to convert grams into milligrams and then milligrams into tablets. So now our 0.001 grams is going to be on the bottom. Our milligrams is going to be on the top. Our milligrams per tablet, the milligrams is going to be on the bottom, and the tablets is going to be on the top. Our left to right math is going to be 1 gram divided by 0.001 equals, on your calculator, divided by 500 equals 2. And again, since these are tablets, you don't have to worry about the sig figs. Finally, I thought I would do a more chemistry type example instead of a medicine one. An iron sample has a mass of 4.5 pounds. What is the mass of this sample in milligrams? So again, what is the mass? That's what we're looking for, the mass in milligrams. We're starting with the mass in pounds. If you look at your table of conversions, we can't go from pounds to milligrams, but we can go from pounds to grams. So on your conversion table, you have the pounds to grams. And then once we go to grams, we can go from grams to milligrams. There are 454 grams in a pound, and there's 0.001 grams in a milligram. So finally, in step 4, we can fill on our number of grams in a pound and 0.001 grams in a milligram. The math would be 4.5 times 454 equals divided by 0.001 is 2.4 times 10 to the 6th milligrams. Here are a couple of dimensional analysis problems for you to do. They're all metric system conversions. So take a few minutes to work on those, and then we'll go over the answer. So to convert grams into kilograms, our first step is to write down grams, because that's what we're looking for. Our second step is the 2.55 kilograms. Our conversion factor here is kilograms on the bottom and grams on the top. 1 kilogram equals 1,000 grams. Always be 1 with the prefix. 1 kilogram equals 1,000 grams. 2.55 times 1,000 is 2,550. And we have 3 sig figs from the initial value of 2.55. Sig figs don't apply here because that's a defined value. The second problem, we're trying to find centimeters in 2.55 kilometers. We can't go directly from kilometers to centimeters, but we can go from kilometers to meters and then meters to centimeters, because both of these, kilometers and centimeters, have meters as their metric system base unit. So kilometers to meters and then meters to centimeters in the second step. Notice when you don't put the numbers in, it's easier to see the steps of where you're going. The kilometers will cancel and go to meters, and then the meters will cancel and go to centimeters. Here's our toolbox. 1 kilometer is 1,000 meters. 1 centimeter is 0.01 meters. So being 1 with the prefix, the 1 kilometer goes on the bottom and the 1,000 meters goes on top. The 1 centimeter goes on top and the 0.01 meters goes on the bottom. Always be 1 with the prefix. Always write the number 1 in front of the prefix. So on your calculator, this would be 25 times 1,000 equals, divided by 0.01 equals 2,500,000. There's only 2 sig figs in this answer because none of these numbers have sig figs associated with them. They're defined values, and the first number only has 2 sig figs. Finally, here's our last example where we're going to have 3 conversions to get from our initial value to our last value. So here, Demerol is ordered 1.5 milligrams per kilogram. So this is a dosage in milligrams per kilogram. So there's 2 units, that's going to go in our toolbox for sure. For a patient that is 220 pounds, since that's a single unit all by itself, we're most likely going to start with that. Demerol is available as a 50 milligram per tablet. That's also going to go right into our toolbox. How many tablets? There it is. How many? That's what we're looking for. How many tablets for a 220 pound patient? Well, first we need to get these pounds into a metric system unit because we can see our dosage, milligrams per kilograms, and our tablet, milligrams, our dose, our pill, is 15 milligrams per tablet. Those are both metric units. So we're going to first convert our pounds into kilograms. Then we're going to put our dosage here in the middle, milligrams per kilograms. And then finally, the number of milligrams in a tablet for our first step. So we're going to use all of the toolbox conversions to get from pounds to kilograms, kilograms to milligrams, and finally milligrams to tablets. The pounds are going to cancel, the kilograms are going to cancel, the milligrams are going to cancel, and finally at the end we're going to be left with tablets. And only when we know the units are canceled correctly are we going to come in and put in our numbers. There are 2.2 pounds in a kilogram. There's 1.5 milligram per kilogram dosage. And finally, there's 50 milligrams in a tablet. For our calculator, we're going to type in 220 divided by 2.2, hit the equal sign, multiply by 1.5, hit the equal sign, divide by 50, hit the equal sign. Do your math left to right instead of top to bottom. 220 divided by 2.2 equals times 1.5 equals divided by 50 equals 3. And here's a learning check that is similar to the problem we just did. So this is a similar problem with a dosage, a tablet, and the mass of a patient. So we're looking for a number of tablets for a 73.5 pound patient. We have to convert the pounds into kilograms so that we can calculate the dosage, and then finally the number of tablets. We convert our pounds into kilograms, then we use the dosage to figure out the number of tablets. 73.5 divided by 2.2 equals times 30 equals divided by 500 gives us the answer of 2 tablets. There's a bunch of really nice links, which again are also in the chapter 2 module.